Hello, everyone. In the previous lesson, we learned about the theoretical knowledge and practical exercises of electric shock first aid. We've mastered the concepts of electric shock injuries, forms of electric shock, causes of electric shock, and methods of first aid. Moreover, we've learned how to perform artificial respiration and external chest compression for electric shock first aid, developing another life-saving skill in our daily lives. Today, we are going to learn new skills. I have 2 questions for you here. Why do some household appliances consume more electricity during their operation? Why do some electrical appliances tend to break down easily? To answer these questions, we will learn about electric power, 3 operating states of electrical equipment, and the measurement of electric power. This lesson covers the following 3 aspects. 1. Electric power. 2. 3 operating states of electrical equipment. 3. Measurement of electric power. Now let's study Project 4 Installation of Electrical Systems for Single-Unit Residences. Project Overview. The electrical system for single-unit residences is widely used in daily life. It's crucial for people to have safe, efficient, and planned electricity consumption, thereby achieving environmental protection and energy conservation. Project Objectives. 1. Gain theoretical knowledge and operational skills through the installation of house lead-ins. 2. Acquire knowledge and operational skills related to single-phase electricity meters and distribution boxes through the installation of single-phase service entrance equipment. This project contains 2 tasks. Task 4.1 Installation of house lead-ins. Task 4.2 Installation of single-phase service entrance equipment. Let's get to learn Task 4.1 Installation of house lead-ins. 1. Task assignment and analysis. Assign tasks to complete switch selection and installation of indoor wires and further understand the criteria for selection of switches and wires, as well as the requirements, classifications, and methods of house lead-in installation. 2. Task objective. Through task assignment, complete switch selection and installation of indoor wires, master the criteria for selection of the main switch and wires, the general principles for house lead-in installation and wiring, and other theoretical knowledge. 3. Implementation methods and steps. In case of renovation of a new house, the main switch and wires should be selected. Complete the table here. By learning this lesson, you will be able to choose the appropriate model of the main switch and wires. 4. Knowledge and skills supporting the task. 1. Electric power. Observe the differences in the filaments of light bulbs labeled with 25W, 40W, and 100W, and then connect them to the same power source separately to observe the differences in their brightness. We find that the higher the rated power of the light bulb, the brighter it is, which means that the current does more work in the same amount of time. Electric power is a physical quantity used to describe the speed at which current does work, usually represented by P. Formula. P equals UI. The unit of voltage U is volts, V. The unit of current I is amperes, A. The unit of electric power, P, is watts, W. The voltage, current, and electric power indicated on electrical appliances refer to their rated voltage, rated current, and rated power. These values represent the highest voltage, maximum current, and maximum power of the electrical appliances during their safe operation. 2. 3 operating states of electrical equipment. 1. Full load, the operating state of electrical equipment at its rated power, also known as the rated operating state. 2. Light load, the operating state below the rated power. 3. Overload, the operating state above the rated power. Since overload can easily damage the electrical appliances, it is generally not allowed. For example, during late-night hours when there are fewer users, the voltage in the lighting circuit may increase, making streetlights particularly prone to damage. Additionally, if household appliances constantly operate in light load or overload conditions, they are more likely to break down. 3. Measurement of electric power. An ammeter and a voltmeter can be used to measure the electric power of an electrical appliance. In practical applications, we often use a power meter to measure the electric power of a circuit. The D26W single-phase power meter shown in Figure 4.1.1 is a high-precision instrument that can measure the electric power of both AC and DC circuits. Instructions for use. The D26W single-phase power meter is a portable Class 0.5 electrodynamic power meter used for measuring current, voltage, and power in DC and AC circuits with a frequency of 45 to 65 Hz. This meter is classified as Class P and is suitable for operation in ambient temperatures of 23 ± 10 degrees Celsius and under conditions of 25% to 80% humidity. The technical specifications of this meter are shown in the figure. The content of this lesson has been fully presented. Let's review the key points of this lesson. Electric power. Electric power is a physical quantity used to describe the speed at which current does work, usually represented by P. Formula: P equals UI. The unit of voltage U is volts, V. The unit of current I is amperes, A. The unit of electric power, P, is watts, W. 3 operating states of electrical equipment. 1. Full load, the operating state of electrical equipment at its rated power, also known as the rated operating state. 2. Light load, the operating state below the rated power. 3. Overload, the operating state above the rated power. The service life of electrical equipment is longest when it is operating under full load. Measurement of electric power. Generally, the D26W single-phase power meter, a high-precision instrument, is used for measurement. Now we can answer the following questions. Why do some household appliances consume more electricity during their operation? It's because they have a high power rating. Why do some electrical appliances tend to break down easily? It's because they are more prone to damage when used in a light load or overload condition. That concludes this lesson. Thank you, everyone.